I figured another example of calculating parallel series circuits never hurts. So here we go. Let's say we have a circuit that looks like this. $10-volt battery, and these two sets of resistors, both in series. I'll make this one be 40 ohms, I'll make this one be 20 ohms, and I'll make this one be 10 ohms, and I'll also make this one be 20 ohms. I'll call them R1, R2, R3, and R4. So that's where we start. And the first thing I normally do is go ahead and calculate the equivalent resistance. And in so doing, I'll have to go through the various steps I'd need to go through to look at the various parts of the circuit where I want to find the voltage or the current. So my first step in doing this would be to go here and say, okay, I'm going to circle these in green. These two are in series, as are these two. So notice that it's a set of two resistors in series, and those two branches are in parallel. But what I can do is I can calculate the series resistance for each branch. And I do that simply by adding them together. So I have 60 ohms here. And this is R1, comma 2. And I have 30 ohms here. And that's R2, comma 3. Bringing this down, I have my battery. $10-volt battery. Okay, but that was the battery's incidental. I don't need that yet. But I do know that across this one, if you like, and this one, there are 10 volts. So I immediately could find the current through both of these resistors just by using Ohm's law and say, whoops, it should be I34. Not R, sorry, this should be 3,4, not 2,3. I'm going to erase that. Sorry about that. So an I34 would be the battery voltage divided by 30 ohms. So I could go ahead and find those currents, and I could then go back up and never even find the equivalent resistance in this case. So I'm going to shrink this down. So since I'm asking for the equivalent resistance, I'll go ahead and find it. So this is two resistors in parallel. It's the equivalent resistance, 1 over it, is equal to 1 over 60 plus 1 over 30, which is equal to 1 over 60 plus 2 over 60 equals 1 over 3 over 60, which is equal to 20 ohms. Okay, so actually this should have been, making a few mistakes here, this shouldn't have been 1 over REQ. I took care of the 1 over here. So REQ is 1 over each of the resistors added together. So that's just the equivalent resistance right here. So I apologize. I made the equation more than it should have been. That's the right equation here. Okay. So it's 1 over 3 over 60, which is 1 over 20, which is 20 ohms. And so that's REQ. Makes sense because it's smaller than either of the two resistors that are in parallel. One's 30 ohms, one's 60 ohms. Now I can find the current through both of those branches. So I1, comma 2 is equal to 10 volts divided by 60 ohms, which is 1/6 of an amp, which is, I think, 0.1667 amperes, or 167 milliamperes approximately. And similarly, I34 is equal to 10 volts divided by 30 ohms, which is 1/3 of an amp, or 0.33 amperes. So I have all my currents. I know the current's going through all four resistors because I know that this one is going to go through both R1 and R2, and this one is going to go through both R3 and R4. So now I just have to find the voltage drops across those resistors and I'm done. And I can do that by applying Ohm's law, knowing they each have whatever current they have going through them, and then multiplying that current by the size of the resistor. Okay, so here I'll say V1 is equal to I1 R1. It's equal to 0.1667 amperes times R1 is 40 ohms. And similarly, V2 is equal to I2, which is the same as I1, times R2, and that's equal to 0.1667 ohms times times 20. I think that's 20. Yeah. And then if you do the math here, boy, it's 40 divided by 6, comes out to about no, not 7. 40 divided by 6 is 6 point. And V2 is going to be 20 divided by 6. It's going to be about 3.33 volts. V3 is going to be equal to I3 times R3. I3 we came up with as 0.33 amps, and R3 is 10 ohms. Which is 3.3 volts, and V4 equals I4 times R4. I4 and I3 are the same. That's equal to 0.33 amps times 20 ohms, which should be about 6.6 volts. There's a little bit of rounding going on here. There should have been 0.333, which would have made this 3.33, and this one would have been 6.67 actually if you went one digit further, or 6.66, but it would basically, when you add these two together, you should get to 10 volts. And when you add these two together, you should get to 10 volts because these two and these two are in series, and they're in series, and if you look around the loop, they are in series with the 10 volt battery in both cases. So this is how you find the currents, the resistances, the equivalent resistance, and the voltage across each resistor. If you want to find the powers dissipated by each resistor, you then multiply the current times the voltage for each of the resistors, and you get the power dissipated by each resistor. All right, I hope this example helps you.